Hey everybody, this is an introductory video on electrochemistry. Or redox reactions, or oxidation reduction reactions. All of those things are kind of synonymous with each other. Just to give you some background, redox reactions or oxidation reactions studies reactions in which electrons are transferred or moved around. So that's what we are going to look at. Okay, so let's first get some basics down. Okay, we probably have to know what the definitions of some of these things are. So the formal name of this is, you'll see here, is oxidation. Make sure that I do this right here. Okay, is oxidation reduction, but you may hear me say redox. Okay, reduction, oxidation. It's just a quicker way of saying this. But an oxidation reaction, or when oxidation occurs, is when something is going to lose electrons. Okay, and then the reduction is when a substance gains electrons. And so this is where I come up with the handy dandy little mnemonic Leo-ger, because my birthday is in August. I like Leo-ger. Lose electrons, oxidation; gain electrons, reduction. Okay, lose electrons, oxidation; gain electrons, reduction. Or you could say oil rig. Oxidation is loss, reduction is gain, but I prefer Leo-ger. It's the August in me. Okay, and so here's the example. Okay, or here's an example. It's not just the only example, but this is an example. Okay, and so if we look, we have iron here. Okay, and we have iron here. Well, iron as a solid has a charge of 0. Okay, the more formal way of saying that is going to be an oxidation state, but the charge here is 0 because it's an element. Iron in this compound is 3+. So what's happening from here to here? Well, iron's going from 3+ to 0. So in order for it to do that, it has to be gaining electrons. Okay, the gaining of electrons is what we call reduction. Okay, now why is gaining electrons reduction? Well, look at the charge. The charge goes from 3+ down to 0, so it goes from 3+ down to 0. So that's a reduction in charge. Okay, now if we look at carbon, carbon has a charge in this molecule of 2+, and here it has a charge of 4+. To go from 2+ to 4+, this is gaining electrons. So if that's gaining electrons, I'm sorry, it's not gaining. This is losing electrons. See how confusing it can be? It's gaining charge but losing electrons. Okay, so if it's losing electrons is oxidation. So carbon is being oxidized, and iron is being reduced. Okay, the reducing agent and the oxidizing agent, now this is where it gets awfully fun here, because let me erase this stuff here. Okay, so what we know here is iron is being reduced and carbon is being oxidized. So now in red, I'm going to show you that iron is the thing that is causing the oxidation. If iron weren't in here, the oxidation wouldn't occur. So this is the oxidizing agent. And the same is true for carbon. If carbon weren't in here, the reduction wouldn't occur. So this is the reducing agent. Okay? And so the thing that's being reduced is the oxidizing agent, and the thing that's being oxidized is the reducing agent. Okay? That's kind of the way it works. Now this leads into a bigger principle on top of that. And the bigger thing that you have to realize is that you cannot have an oxidation without a reduction, and you can't have a reduction without an oxidation. Those electrons have to go someplace in a chemical reaction. Okay, so if this gives off, if this is a reduction and it gains 3 electrons, right? That's what we're saying. Those electrons, those 3 electrons, have to come from someplace. Okay, where are they going to come from? They're going to come from the carbon being oxidized. So oxidation has to occur with a reduction. Okay, and yeah, so there are some basics of redox reactions, and that's it for now. Have a great day.